The traditional LLM stuff is used for communicating with Timeseer, like what kind of data check I need to apply, for example, or how do I need to interpret these results. So you can communicate with the Timeseer using the LLMs, but using the time series foundation model is more for the augmentation. Because if you have to see it like that, if data is used like for billing, for arbitrage, or for sharing, and it's not good enough, you want to have conviction and that it's good enough, that the version that you share. So you need to augment. So it's really a must-have to unlock certain use cases to have a clean version of that data.
Welcome back to the Industrial IoT Spotlight Podcast. I'm your host, Eric Walenza, the CEO of IoT One, and our guest today is Bert Baeck, co-founder and CEO of Timeseer.AI. Timeseer.AI is a time series data operations software company that automates data orchestration throughout an organization. In this talk, we discuss the growing challenges of managing time series data as data volumes grow and as organizations become increasingly reliant on real-time analysis for automation and decision-making. We explored the impacts of data downtime and approaches to make time series data more trustworthy by empowering data teams to detect, prioritize, and investigate data quality issues before they hit the operations. We also discussed how to define data quality metrics and establish building blocks for improving IoT and OT data quality and observability. Finally, we defined the responsibilities of a data ops team and their fit in the broader IT organization. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have a research strategy or innovation initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you.
Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Bert, thanks for joining us on the podcast today.
Hey, welcome, Eric. Nice to be here.
Yeah, great. Bert, I'm looking forward to this one because you're an entrepreneur, I would say kind of a serial entrepreneur in that you had a successful exit. Maybe you can share a little bit about that. But then you've also been involved, from what I see from your LinkedIn profile, with, 20 quite interesting companies right now as an investor, a director, an advisor of some sort. So maybe a good point to start here would be explaining a little bit, why did you choose, out of all the things that you're involved in right now, why did you choose this particular topic to dedicate this part of your life on?
Yeah, so that's a long story that I will bring short. It all started with a background in data science very early on. Back then, nobody talked about AI. It was big. It's called data mining, and so even statistics we were trying to do. So an engineering degree. I ended up in a chemical company called Bayer, a German company that now calls Covestro. And very early on, I got sparked on the potential of process data like OT, IoT data, where not a lot was happening, and the majority was just stored in OSI soft PI. And I got sparked on that idea, right? So that was the first transition. And that company became TrendMiner, which is, a long story short, there is a self-service analytics company with basically a search tool for OT data, like a tool for process engineers where they can do root cause analysis and troubleshooting. That was an interesting ride because in the end, it was like a competition, a race between another company, us, TrendMiner and Seek. And we both did quite nice, and we got acquired in 2018 by Software AG, and Seek is still in the market as an own company with private investors. And after that exit, I didn't stay that long at Software AG. I was quite more motivated to try something else. And I was on board as a partner in a venture capital firm. So I was in Belgium, Smartfin Capital. They were in my cap table with TrendMiner, and the partner said, like, Bert, come in. You will be a good partner for AI investments, analytics, industrial software. And basically what happened, that's the why of Timeseer, is 3 years in a row, seeing a lot of deal flow. So companies you can review. And I started to notice deal flow with respect of data quality. And whoa, data quality. This is an old category, right? This is boring. Nobody likes data quality. But why is it suddenly so investable? And it made sense at a certain point of time by one, companies were solving the problem of data storage at scale. So you can store data to the cloud at scale. That's called big data. They can compute at scale, check the box. They can do that too. So it was exactly the moment in time what I call the great unlock, where companies start to build data-driven applications. And that's also the moment in time where quality is really mattering. And that brings me to Timeseer, because all the companies I noticed popping up in data quality, data observability, they were all focused on two things: structured data, relational data, and mainly the data was already landed in Snowflake or Databricks, and you start there. Well, if we look to IoT data or OT data from factories, that has a complete different lineage, and the technology was not really built for IoT data. So I decided that we wanted to build a second company after TrendMiner, and that became Timeseer. So 100% focus on data quality, data observability, but for IoT data. And that is the story from start to now. And the other companies are more advisory, investor, angel roles. But Timeseer is my full-time kind of commitment and passion, what I'm doing.
Yeah, okay, great. Yeah, the last podcast that I hosted last week was with the CEO of a company called Barbara. I don't know, are you familiar with them?
I know them, but never looked in detail on what they're doing. But I know the name.
Yeah, so they're providing a different solution than you are, but they're also dealing with IoT solutions, a lot of process industries.
Okay.
And I think the trend that they're building around is this trend of companies migrating away from cloud-based solutions towards edge solutions because of some of these data challenges, right? So the cloud solution is great for hosting a lot of data, but of course that's very expensive. It's great for AWS. It's not necessarily great for the end customer. And so this challenge of cleaning up the data, making sure you're only storing what is the high quality data that you need in the cloud, and I think is an increasingly significant challenge. And then once you start migrating things to the edge, of course, you need to make sure that you have actual good quality data that you're working with there. Where do you fit into this overall solution stack? So I guess a lot of companies are going to be familiar with their cloud providers, and they'll be familiar with the end user applications that they're using. Where would you fit into that ecosystem, and who would be the direct buyer and user of your solutions?
Good question. Basically, when you say data quality management is part of a bigger team, which is data governance, where data governance typically has a driver like we want one version of the truth, like we cannot depend on too many different sources that have the same data and people manipulate them. So data governance is a very important dominant factor. Then data ops is also data operations is part of the data governance market and category. And there indeed you see in data ops, there's data quality management, indeed taking care of that you go from raw, uncurated, unverified data to whole level up to high quality data, repaired, augmented in the right format, so transformed. So that whole transition is part of what we call data quality management. And yeah, that's basically where we fit in as a category. And if you look to the solution space, basically, if we wind back, what happened was the companies out there were focusing on digital transformation. So all our clients, they first invested in data storage. That typically was indeed acquiring and buying and implementing data historians, IoT platforms, so making sure data is landed somewhere that they can move. But what happened was after they had the data in their stores, the whole ecosystem moved from data storage to data consumption, analytics, the dashboards, AI models. So we basically jumped from storage to consumption. And what was happened a little bit in hindsight is that all these things are not really scaling. So a lot of AI is also in a state what we call AI sobering, where it was not fulfilling the desires, stuck at proof of concepts, not really scaling from one asset to 1,000 assets that they have. And one of the reasons indeed is the data quality. And what you now see happening is that the solutions in the AI stack, some of them have data quality as a feature, but it's really moving out of the analytics stack and moving into the middleware. So where are we? I would say between storage and between data activation, data consumption, and that's the data middleware where data will be prepared for usage, and also link things like the medallion concept of Databricks, where we have silver, bronze, gold tiers of quality, And then all the tools that use data will tap into that kind of data catalog. So we really fit in between the storage and like the consumption.
Okay. So I guess the dynamic is somebody invests in their infrastructure, then they start deploying applications, and then they figure out that the applications are not scaling or quite doing the job that they wish they were doing. And then they start investigating the data quality. Does that mean that you're typically going to be selling directly to the IT team, or is it often going to be some sort of collaboration with the cloud provider or the application, the key applications that they're obtaining data for?
A combination, because, for example, if you only talk to IT, you see that they would tend to work with their IT tooling, like, oh, we have Databricks, let's solve it in Databricks, and they start building things themselves in a MacGyver way, like do-it-yourself is very popular, or very good tooling like Databricks, for example. But the moment you talk more to the operations and the sensors and the devices, then they understand like how difficult it is to apply data quality on the edge for devices and for sensors, because you have the physics, you have the first principles, there's like the sensor specifications. Is this possible? There are the relationships between devices and how they need to behave. So you tend to go very deep into domain expertise, where you need to understand devices and sensors. And then indeed you need to glue the OT people with IT. So it's really like a combination. But if you look from a budget perspective, it's mainly IT, like the chief CDO, chief data officer, chief digital officer is typically the driver to get the data into shape. But you need the OT people too, and also the data stewards, because if data is not good enough and somebody needs to validate, you need to have people understanding that OT, IoT data. So we see a mixture there, to be honest.
Gotcha. It sounds like you're getting pretty close down to the edge. So where would you be deployed? You'd be deployed on the sensor, on the hub or the gateway. Would you also be deployed in the cloud, cleaning up data after it applies, or making sure you're not duplicating data there? Where would you be touching the data?
Mainly, there's a big rejection to move data, right? So, for example, if I bring in technology and I first tell you as a client, you need to move your data to Fabric or to Amazon or put it in Databricks, there's big resistance towards that. So our philosophy was from day one, let the data reside where it's generated. So what is happening with Timeseer, what we developed is a sort of an agent. And you can compare that with virus scanners back in the days where you were scanning for viruses everywhere you had systems. Well, we are scanning for quality everywhere the data is residing with our agents. That can be the edge, it can be the fog or the historian, it can be clouds, multi-clouds, managed cloud. So we are very hybrid in a way where we can scan the data. But what we do is we propagate our results of data quality up to a control tower philosophy. And that's, of course, mainly cloud, right? But it's a very important design criteria that we can scan data where it's generated. So it can be even on the edge, like on a connected car or on a sensor or on an aggregator.
So hybrid approach, orchestrated, but then you have these certain principles about not moving data. I guess there's a cost perspective, there's quality, or there's security perspectives there. Of course, you're managing the quality of data. I guess the cost is another issue, right? This question of what data do we save? How long do we save it? So what are the different types of problems that you're focused on solving? And maybe you can also help us to understand at these different levels that you're operating at, there's probably a different sets of problems by level.
Yeah. So what we see as common thing is, of course, when you talk sensors, devices, you work with operations, right? So a lot of Fortune 5,000 companies have sensors in the fleet or in the heart of their operations. So that is where you all start in the business process. But to see where the use cases we typically see is there are a couple of them. And of course, data quality should be a must-have. If it's just like, data quality, we understand, but where is it impacting us? It's a very big problem. So I'll give you a couple of examples where it has no impact and why. And then I'll give you a couple of examples where data quality has impact and also why. Let's first, for example, start with an industrial factory in mind. If there is, for example, a control room and an operator, a human in the loop, there is like DCS, SCADA, PLC, a safety system, an alarm system. Well, what we see is for factories, data is typically good enough for operations, so they don't care about quality because when it's stored, they are operating the plant, for example. So there we see not a good fit for data quality. But data quality is, of course, once it's stored and it's in your database, it will be used for something. And there are typically use cases where we see like it's really impacting. One of them is, for example, data sharing. we see a lot of our clients that have sensor and device data that are sharing data, one, internal with people like their stakeholders, but also external with suppliers, with their customers. And of course, if you share data with your suppliers or with your customers, it should be spot on, right? Because you create like a liability. Also, data sharing is a very important use case where we've proven that data quality should be spot on. Another one is dashboards that are, for example, public for governments, like emission data, data for energy consumption. If I'm reporting energy, it should be right. So there's also governance, why data quality important, that kind of data products. Then there's a third kind of bucket of use cases where companies or clients of us are ramping up with analytics and AI, and they were a little bit stuck. Like they tried something and they were stuck at proof of concept and figured out that if I want to go from one asset to 20, 30,000 assets, it will never scale because it will take us too long, the onboarding time, the data prep time, and they need something that helps them in scaling up their AI models. And there we see data quality as a game-changing element. One, at training, you get better data models. Second, you will experience machine learning efficiency, like data teams spend less time on cleansing and prepping data. And the third one is sometimes these models in production, like predictive maintenance, they generate false alerts. And these alerts come because the input data, the sensor data, was not trustworthy. And that's something we do at inference. So we check data integrity at inference to, for example, when there's a model running, you can say, oh, don't trust this prediction. It's a false alert because your sensor is behaving wrong. So we see value over there. And a fourth use case is indeed just embedded in data governance. We see a lot of companies buying data governance tools, creating data catalogs. And of course, there also need to be an IT, OT counterpart in a data catalog. And that is something we build for catalogs. So we try to be very ecosystem friendly, not cannibalizing, but just helping to unlock all these use cases.
So the first two seem quite straightforward. Those are kind of compliance use cases, right? So just hitting a certain accuracy level. The third one, maybe we can drill into that a little bit deeper, because this is a topic that I've seen a lot of companies that we're working with struggle with. So things like this predictive maintenance, right? Working on a production line, you have 50 production lines across some plants. They all have similar hardware. So they should be the same, more or less. But then in the end, deploying a predictive maintenance solution ends up being 50 different projects for each production line. And then you kill the business case. So if we use that as a situation, how would you fit into that scenario?
Yeah, so it's very important. Those predictive maintenance companies, they would be a partner from us. So we would work with them from an OEM perspective. So that means like the end customer does not know Timeseer is in the middleware of the PDM, predictive maintenance solution. I think that's one thing to come clear. And what's happening there is indeed you just want to move the needle in the different steps of the value chain. And I think indeed, as always, the first thing is you have to build a model. And if you build a model and you can create your model based on verified data, for example, by Timeseer, what we've seen from results is that we see much better model quality, sometimes up to 60, 70% better models, because it was trained on well-designed data, like it was already cleansed, it was clean, pre-processed. So we see that data quality there is paramount and moving the needle at training. That's training your model, right? That's the first thing. A second one is scaling that up. If you don't have one asset, but you have thousands, what we typically see is that there's a struggle indeed with too long onboarding times. I always have to do the same training over and over. What's helping there is data uniformization, unified namespace. You see there indeed conventions like data contextualization, so adding context so you can have better data models to train your AI models on is all helping to get in a faster shape from how to move from 1 to 1,000 assets. For example, if that's like a desire. So that's more on like the scaling element. How can we scale from 1 to X assets? A third one is indeed more when that model runs in production. And indeed what you see there at inference, you see a lot of issues with scalability, but also like with robustness and accuracy. And there you need to help like move away from the false alerts. Like your predictive models should only come forward when they have a real alarm, something that is really going on, not a sensor problem. But from a value perspective, we fit in, and the end client does not know that Timeseer is used. So you see dashboards with health scores of how good the data is. So it's completely end-to-end integrated. So I also listened to a couple of the podcasts here. I saw indeed some companies working on predictive maintenance. Well, they could embed Timeseer, right? So it's an OEM mindset that we have there.
If you're still listening, then you must take technology seriously. So I'd like to introduce you to our case study database. Think of it as a roadmap that can help you understand which use cases and technologies are being deployed in the world today. We have cataloged more than 9,000 case studies and are adding 500 per month with detailed tagging by industry and function. Our goal is to help you make better investment decisions that are backed by data. Check it out at the link below, and please share your thoughts. We'd love to hear how we can improve it. Thank you, and back to the show.
You mentioned earlier this concept of data ops. How mature is that? Because I guess the concept kind of stems off of DevOps, which is quite well structured, and people have kind of receive training and specialize to some extent in that capability. If you're working with companies today, are you finding kind of a relatively well unified understanding of how data should be managed? So what data ops should be looking like? Or are you finding that each companies or different companies are kind of inventing their own processes there? What's your sense of how mature that part of this equation is?
It's for sure maturing, like with the popularity of use cases like asset models, digital twin, topics like UNS, unified namespace. We see indeed vendors, automation vendors, adapting and also understanding that it's really critical that, for example, you need a unified namespace and you need good quality data if you all want to unlock all these use cases we discussed a couple of minutes ago. So these are prerequisites. What I mainly saw is a couple of years ago, companies saw them as like, yeah, there are projects, we don't have time, we don't have resources. But if you're really blocked in your attempts to scale up data products, to scale up analytics, and you figure out the why, and the why is like, oh, data's not good enough and not in the right structure, you need to solve that first, right? If you really want to move forward with your analytics and AI. So we see now more and more companies understanding that.
Yeah, and the reason I'm asking is that we also see quite a trend of operations building their own kind of IT capability and trying to move away from IT or reliance on the traditional IT department. I think in many companies that's been seen as somewhat of a bottleneck in terms of rolling out new systems. But then, of course, there's kind of this capability issue on the ops side. I mean, how do you see this? And maybe one extension of this could be the topic of generative AI, which I know is something that will be probably late to come to operations, but already I hear about companies using generative AI in some areas of their applications, right, as extensions of how to interpret time series data, for example. But that also would enable the ops teams to be more independent when it comes to developing applications. So can you share your thoughts on that trend, and then maybe also on the trend of generative AI, if you think that there's something interesting to share here?
Yeah, there's an interesting link to make. So I indeed see a lot of generative AI blogs and then like posts on LinkedIn, and if they frame manufacturing or IoT, it's always indeed LLM based, and where you can interrogate and then communicate with your results, which completely makes sense, by the way. But there's also like a generative AI concept where in time series there are also now foundational models popping up. I see more and more time series foundational models, and these can be used, for example, to create data. So, for example, if we identify we have gaps or we have data that's not good enough and we want to clean, how will you clean? Well, that's also generative AI, right? But you just apply background models. What I also see popular in IoT is the concept of federated learning, where, for example, you are learning on the behavior of one device across your entire fleet of assets. And then, of course, the more devices you see, the better models you can train. And you can, again, use that then for generative cleansing if there are, for example, gaps. So for data cleaning, I see a big part of generative AI being used. And second is also for metadata. There's a lot of metadata out there that is describing how your sensor fleet, like specifications, configurations, and not good enough, or like not complete, or inconsistent. And of course, metadata is very critical if you want to move into a next step. So also for metadata, there's generative AI techniques applied to start augmenting that, to start creating better context models, better metadata. So I see it more used and different than typically we talk about language models. I see it really used based on time series foundational models.
And for your tech stack, have you already started to adopt some of these foundational models?
Yes. For the augmentation and the cleansing, and the traditional LLM stuff is used for communicating with Timeseer, like what kind of data check I need to apply, for example, or how do I need to interpret these results. So you can communicate with the Timeseer using the LLMs, but using the time series foundation model is more for the augmentation. Because if you have to see it like that, if data is used like for billing, for arbitrage, or for sharing, and it's not good enough, you want to have conviction and that it's good enough, the version that you share. So you need to augment. So it's really a must-have to unlock certain use case to have a clean version of that data.
Got you. And are you using the same LLMs that somebody might be using for, I guess, language models? That's going to be separate. So are you using more open source, or what would be the LLMs that you would be building on?
Open source like Llama.
Yeah.
And testing
Okay,
how to embed them. Yeah. But also have the concept of the racks to use and see how people are using the tools to optimize your LLM usage. So we're also experimenting with that learning. So for us, learning is very critical because you need to adopt something, learn of other assets, other prior events. So learning is critical.
Yeah. Okay. Got it. And are you finding that they also deploy fairly well on the edge already, or still work in progress in terms of being able to deploy it?
Work in progress. I see the data scanning on the edge is something mainstream that's really possible already with the current technologies. But indeed, the complete cycle end to end, that's still early. I see the majority of applications built on data stores like Databricks oriented or Fabric or Amazon S3. So I see the majority still built on cloud infrastructure.
Okay. Let's talk a little bit more then about the customers that you're working with. I mean, this is to some extent a horizontal problem, but are you finding specific industries, specific types of challenges that end up being kind of the 80-20 or the 80% of your customer base, or is it just a very fragmented market?
The company's name is Timeseer, so it links with time series. So when we started up, it was like horizontal time series. But what we figured out is we needed to make it smaller. And for it's really now today OT, IoT, so both. That means when you talk OT, you would work more with manufacturing, plants, utilities, pharmaceuticals, biotech, oil and gas, upstream, downstream. So that's more OT in the wired space. But the moment you look to IoT, you end up more with connected things, connected assets, connected patients, connected athletes. So everything with a sensor on, connected washing machines. So what we see is that we have a variety of clients. As long as they have sensors in the hardware operations, the Timeseer stack holds. And what we build from start first cleansing and then verification, validation, it holds as long as we talk sensors and devices.
Okay, but that's an interesting point, right? You could have an F&B manufacturer who would deploy your solution across their facility, but then you could also have, a lot of OEMs right now are trying to differentiate their solutions by adding sensors and then capability on top of that. And then as much as possible, they want to keep their some degree of control over the application. So are you finding a lot of those equipment OEMs or those sensor OEMs becoming direct customers of yours?
Yeah. So that's what I would call XaaS, everything as a service. We see indeed oil and gas companies, for example, we have a couple of names like a Baker Hughes or a Veolia, who are indeed having their own assets and IoT devices and selling an application to their clients for a higher degree of service, or for getting warrant on we have empty tanks, or for helping in predictive maintenance. And there, indeed, you see that the quality part is critical, and you see it at Timeseer fit in their OEM solution, and that's always linked with everything as a service. They're trying to monetize different and move from capex to opex and charge their customers different and go to an opex model. So I see that transition, and we sell indeed to these clients.
Yeah, there's maybe an offshoot that, in my experience, has been underdeveloped, but this offshoot of data sharing, which is data monetization, right? That somebody is developing data that has value for multiple stakeholders, but just sharing the bulk of the data would be challenging for regulatory or other reasons. It strikes me that your solution could be also applicable here, and if you're able to specify what data can be shared with which stakeholders. Do you see any movement towards efforts to monetize data? I mean, it feels like one of those problems where the technical feasibility is there, but there's still a lot of kind of legal or business challenges that need to be resolved.
See first use cases, but not in a way that we can. I can already say like, yeah, happening at scale. But for example, one example I can give is where you have a chemical factory who is sharing data of their very complex analyzers with the sensor manufacturer, and they found a win-win. Like they sharing data back to the supplier, and what's happening is they go from time-based to condition-based calibration. So that's a win-win in like a cost saving. And because that cost saving is helping the chemical manufacturer because it's saving costs, but also like the vendor of the sensors can give a better kind of service. So what I see where data monetization is being used is where indeed when I share it, it's generating a win-win. And that's what I already am seeing that indeed chemical companies are experimenting first steps, but it's happening.
Got you. Okay, so it's happening now with these very direct relationships from the operator to the OEM, but maybe there would be third parties that would also find some value in that. So let's say the financial services part, companies would love to have direct streams of data, and I guess that's maybe a bridge too far right now. Although I've heard some companies that were working on that problem, but never, to your point, never one that found the right way to scale that up. Bert, I feel like we've covered a good bit of ground here. What haven't we touched on yet that's important for folks to understand about time series data?
If you would analyze the category data quality, you will probably end up always with the horizontal vendors. What is maybe interesting to reemphasize or to talk about for a second is why is the sensor different, right? Why is sensor data that different? And sometimes it takes like the hard way to figure it out. And one of the reasons is that, for example, often you don't have background models. For example, let's take a relational database and there's like names and addresses. Well, we know how an address should look like. We know postal code, so we know what the good is and the bad. But if we have time series data from a sensor, how do we know it's good? So if often you don't have that context of what is good and what is bad, and you need to have the people who understand the data to make an interpretation. That is one. What also is really different with time series data is like the lineage. The data is not in Databricks, right? It started on the edge, generated by a sensor, and it came maybe via data store, and it ends up in the cloud. But it has an all different kind of lineage or path it travels. So that is quite different. And also, typically, when you talk about normal horizontal data quality solutions, the first triage or how you solve problems, it's done by IT or different people. When you talk sensors and there's something wrong, well, your triage is, I need to find instrument technician. He needs to go in the field, he needs to repair or need to check the sensor or do some maintenance. So the concept of first triage is completely different in the sensor world. So that is why I see IoT and OT sensor data quality is something completely different than working on top of Databricks and Snowflake.
Yeah, great. And maybe even becoming more so, right? Because in the past, a lot of that data was either operated on quite simply on the edge, or it was transferred somewhere. Now we're really doing more complex things with AI on the edge, right? Which requires different processes than were required in the past. Maybe last question then. You guys are, about 4 years old now? I'm sure you have a very ambitious product development roadmap. If we look forward over the next year, what is on the roadmap for you guys?
What is on the roadmap? So this is a deep tech product. So sometimes when you talk to investors, like you have a SaaS mindset, this is not SaaS because it's not something you develop over the weekend. It really has deep down AI components embedded. So making that robust and scalable for millions of sensors, not just like a couple, really took a long time. So we had our version 1 only shipped end of last year. But what's really on the roadmap is incorporating some more AI concept in the data quality. So what I typically tend to say is everybody today accepts that AI needs data quality because without good data, you don't have scalable AI. But tackling data quality at scale also needs AI, and it comes in various forms like co-pilots that help you in result interpretation or making smart summaries or helping you in configurations or in communicating with results. The learning, like can we learn from different assets that are similar across clients even? So all these AI concepts we see that really as game-changing and necessary to win this category. And that is something we heavily are investing in and launching over the next couple of months.
Great. Well, it must be a super interesting time right now, right? I mean, AI is evolving very quickly in a number of different ways. So lots of change going on that you can benefit from. Bert, what is the best way for folks to reach out to you or to the team if they're interested in learning more?
There's, of course, our website, Timeseer.AI. There's LinkedIn. We try to post a lot of content because thought leadership is very important in early categories on educating prospects, clients on why data quality is important, what use cases are typically happening. We are working on a product-led growth version that can be used by data scientists for free just to play with Timeseer, because how is the onboarding? So best is to engage directly, websites, contact us, or via LinkedIn, where there's interesting content.
Yeah, fantastic. Bert, thanks so much for the time today.
Welcome, Eric. Enjoyed it. Thank you.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.